Hi, myself as well. Then I'll be talking about the adapter design pattern and how it's going to be used in the object-oriented mobile phones. So adapter is a design pattern. We'll start with an example of how it's going to happen. Consider we are now in the drawing tool application development. Sometimes a toolkit class that's designed for the use isn't usable only because it's interface as class domains is an application requires. Consider, for example, as I said, a drawing editor application which lets users draw and arrange political or like a graphical elements, lines, polygons, text, etc. into pictures and diagrams. The drawing editor's key abstraction is a graphical object which has an external shape and can draw itself. The interface for graphical objects is designed by an abstract class called shape. The editor defines a subclass of shape for each kind of graphical objects. A line class for lines, a polygon class for polygons, and so forth. So classes for elementary geometric shapes like line shape and polygons are rather easy to implement because their drawing and editing capabilities are inherently limited. But it takes shape subclass, that is a font that can display and edit text is extremely more difficult to implement. Since even basic text editing tools involves complicated screen update and performance expert. Meanwhile, an on and off shelf user interface toolkit might already provide a sophisticated text view class for displaying and editing text. Ideally, we would like to reuse those text view to implement the text shape. But the toolkit wasn't designed with the same class in mind. So we cannot use the text view and object shape objects interchangeably. So how can we can make this problem solve it? So here we are having the existing and available classes like text view and the shape view. Will be trying to use these reuse these interfaces of shape objects into the shape text view. So say we could change the text view class so that it conforms to the shape interface, but that isn't an option unless we have the toolkit source code. Even if we did, it wouldn't make sense to change text view. The toolkit shouldn't have to adopt domain-specific interfaces just to make one application work. Instead, we could define text view so that it adapts the text view interface to the shapes. We can do this in one of two ways. One is by inheriting shapes interface and text views implementation. The other one is by composing a text view instance within the text shape and implementing text shape in terms of text view instance within the text shape and implementing text shape in terms of text views interface. These two approaches correspond to the class and objects versions of the adaptive pattern. So here comes the adaptive pattern. So we call this text shape an adapter, which adapts the text view interface to the shape interface. So often the adapter is responsible for the functionality the adapted class doesn't provide. Text view text shape can add this missing functionality by implementing shapes created create manipulator operation, which turns an instance of the operator appropriate manipulator of class. Manipulator is an abstract class for objects that know how to animate a shape in response to the user, like dragging the shape to a new location. There are subclasses of manipulator for different shapes. Text manipulator, for example, is a corresponding subclass for text shape. By returning a text manipulator instance, text shape adds the functionality that text view lacks but shape requires. So coming to the intent of the abstract class, it's about convert the interface of a class into another interface that a client expects. Adapting lets classes work together but couldn't otherwise because of incompatible interfaces. Right. And then the applicability of the adaptive pattern is you want to use an existing class and its interface does not match the one you need. That's where you have to use the adaptive pattern. We want to create a reusable class that cooperates with unrelated or unforeseen classes. That is, Classes that don't necessarily have compatible interfaces. Object adapter only, where you need to use several existing subclasses, but it's impractical to adapt the interface by subclassing everyone. An object adapter can adapt the interface of its parent class. Right? And then the participants of the adapted classes are target. Defines the domain specific interfaces that the clients uses, and then the client collaborates with objects conforming to the target interface, and then the adaptee defines an existing interface that needs adapting. So this adapter adapts the interface of adaptee to the target interface. Collaborations of the adapter class. Clients call operations on an adapter instance. In turn, the adapter calls adaptive operations that carry out the request. The consequences of using the adapter class. Class and object adapters have different trade-offs. Trade-offs such as a class adapter adapts adaptive to target by committing to a concrete adapter class. As a consequence, a class adapter won't work when we want to adapt the class and all its subclasses. Let's adapter override some of adaptive's behavior, and since adapter is a subclass of adaptive, introduces only one object and no additional pointer interaction is needed to get to the adaptive. An object adapter lets a single adapter work with many adapters, that is, the adaptive itself and all of its subclasses. And the adapter can also add functionality to all adapters at once. And an object adapter makes it harder to override adaptive behavior. It will require subclassing adaptive and making adapter refer to the subclass rather than anti-adaptive itself. Some of the issues considering when using the adaptive pattern are adapters vary in amount of work they do to adaptive to the target interface. It's a spectrum of possible work from simple interface conversion, for example, changing the names of the operation to supporting an entirely different set of operations. The amount of work adapter does depends on how similar the target interface is to adaptive. Pluggable adapters. A class is most usable when you minimize the assumptions other classes must make to use it. By building interfaces, adaptation into a class, you eliminate the assumption that other classes see the same interface. Put another way, we could say like interface adaptation lets us incorporate our class into existing systems that might expect different interfaces to the class. Let's say consider a tree display widget that can display tree structures graphically. If this were a special purpose widget for use in just one application, then we might require the object that it displays to have a specific interface. That is all must descend from a T abstract class. But if you wanted to make tree display more reusable, then that requirement would be unreasonable. Application will define their own classes for tree structures. They shouldn't be forced to use our tree abstract class. Different tree structures will have different interfaces. In a directory hierarchy, for example, children must be accessed with the subdirectories operation, whereas in the inheritance hierarchy, the corresponding operation might be called get subclasses. A reusable tree display widget must be able to display both kinds of hierarchy, even if they use different interfaces. And then the other issue with adapting to the adapter patterns, a potential problem with adapters is that they aren't transferred to all times. An adapted object no longer conforms to the adaptive interface, so it cannot be used as is wherever an adaptive object can. Two-way adapters can provide such transparency. Especially, they are useful when two different clients need to view an object differently. And then the solution involves a two-way class adapter, constant variable, and a subclass of both state variable and constant variable that adapts the two interfaces to each other. Multiple inheritance is a viable solution in this case because the interfaces of adapted class are substantially different. The two-way class adapter conforms to both of the adapted class and can work in either system. The implementation issues. that have to be kept in mind while using the adapter pattern is implementing class adapters in C++. In the C++ implementation of class adapter would clear it publicly from target and privately from the adapter. These adapters would be some type of target, but not a out of adapting. Pluggable adapters. Let's look at three ways to implement pluggable adapters for a three different earlier, which can lay out and display and hierarchically structured graphically automatically. The first step, which is common to all of the implementation description, is to find a narrow interface for adaptation. That is a smaller subset of operation that helps us do the adaptation. A narrow interface consisting of only a couple of operations is easier to adapt than an interface with dozens of operations. For tree display, the adapter is a hierarchical structure. A minimalist interface might include two operations. One that defines how to present a node in the hierarchical structure geographically, and the other that retrieves the node's signal. So three implementations of this are the first one is using abstract operations, and then using delegate objects, and then parameterize adapters. So actually the parameters are the useful way to support pluggable adapters is to parameterize an adapter with one or more blocks. The block construct supports adaptation without subclassing. A block can adapt a request and the adapter can store a block for each individual request. Now, example, this means tree display stores one block for converting a node into a graphic node and the another block for accessing a node symbol. The related patterns of the adapters are bridge. Bridge has a structure similar to an object adapter, but bridge has a different effect. It is built to separate an interface from its implementation so that they can be made easier individually. An adapter is built to change the interface of an existing object. And the same pattern is decorated, which enhances another object without changing its interface. A decorator is thus more transparent to the application than an adapter is. As a consequence, decorator supports recursive composition, which isn't possible with pure adapters. The third one is proxy, finds a representative and surrogate for another object and does not change its interface. With all these things, I hope you have got enough knowledge about how adapters are used in the object-oriented world for creating and manipulating objects as well as classes with its methods and functions. Thank you.